Okay, here's my next example. Pause and copy all the stuff in green. Now, we want to convert our limits of integration. So we got a 6 and a 3. Now, if I plug in 3 here, I get secant theta is 1, which tells me that cosine theta is also 1. And then to solve, in this case, we'll actually use our we'll use our inverse trig, our cosine of 1. So our cos of 1 is definitely 0. So you'll remember that the range of our cos is 0 to pi. So you would not get, say, 2 pi here. You gotta get 0. Okay, similarly, if you plug in 6, you get secant theta is 2, cosine is a half, and again you get theta is pi over 3. Okay, so if you're not careful, you may choose theta is, well, I'm not sure why you do that, but you may say, oh, what about negative pi over 3? Well, not today. Okay, moving on. We've converted our bounds. The 3 is going to become a 0, and the 6 is going to become pi over 3. Before we do that, we find dx as usual. And then we plug in all the things we have found. Compute, compute, compute. Computer gives us this tan squared. Tan squared is okay because tan squared can be related to secant squared. So I do that using the appropriate trigonometric identity. And then, oops, the rest I think is straightforward. You are doing a definite integral. So pause and copy that. Beep, boop, boop. Bop, bop, bop. So notice I did not need a triangle. All right, so that was a nice feature of converting the limits of integration. Okay, you may recall from 5.5 substitution, we have the option of converting this back into x's and then using the original limits of integration, but we've avoided that step by converting the limits. Okay, you could technically use a triangle to convert these back to x, but I think this way is much easier. Okay, exercise for you to contemplate. I give you the answer. Somewhat unpleasant. It is actually unpleasant. I think it's a difficult one. Okay, so do not be concerned if you're having trouble with this. Okay, but if you're ever in trouble, it's a great chance to stick your nose in your textbook. This is done in full in 7.3.